Welcome! In the last lecture, we created this basic time of day and a variable for dawn time, a variable for our dusk time. Now, by changing this slider here, we can change how our sun should rotate. And the next thing that we need to solve is, after this variable time of day passes dusk time, our scene becomes completely black. And that's because we haven't really specified what should happen inside of this time slot. And we'll look at how we can handle this in this lecture. More specifically, we need to handle the rotation for our moon. And let's be clear about what we want here. So we know the valid rotation range is somewhere between 0 degrees and -180. But the rotation of the moon is slightly different from our sun. What we really want to specify here is what happens after dusk and what happened before dawn. So before our sun is visible, how should our moon behave? Take this after dusk, for example. The valid range should be between -180 to -90, and our moon should rotate like this. And for the before dawn, the value range should be between -90 and 0 degrees. And this is how our moon should rotate. This is going to make much more sense to you once we start coding. And before we do that, there's one thing that we need to know. So now I'm going to change my time to 7. So our sun is at that direction, and we need to know the exact time our sun comes out. So currently the dawn time is 6 AM, and if I change this value to 6, you can see our sun is below the horizon, but we can still see the impact it has on the sky atmosphere. And if I change this value to 5.6, you can see our scene becomes black. Now if I change this to 5.8, and that's when our sun starts to appear. So about 0.2 units earlier than this dawn time. Since now we are using a value of 1 to represent 1 hour, so 0.2 is about 12 minutes. And same thing goes for this dusk time. So if I change this value to 18, and we can still see the impact of our sun. Now if I change this value to 18.4, our sun disappears. So I'm going to change it to 18.2. Our sun is still there. So this is something that we should take into account when we are handling the moon. Alright, let's start coding. I'm going to go inside of this dynamic sky. And for our moon, we'll need a second directional light. So I'm going to select this default scene route, click Add, and type in directional light. I'm going to change the name to Moon Directional Light. And just to distinguish this from our sun, I'm going to lower its intensity down to 1. So this is a lot darker than our sun directional light. Then I'm going to drag out this moon directional light. And same as this sun directional light, we'll need to set its rotation. So I'm going to duplicate this node, select it, and press Ctrl+D to duplicate it. Connect this one to target. Connect this pin to here. Now for the rotation pitch, we'll need to use the same function. So I'm going to select this one and select this time of day, press Ctrl+D to duplicate them, and connect this one to here. So for this in range A, I'm going to go to basic settings, hold down Ctrl on my keyboard, drag out this dusk time. Its input range should be between dusk time plus 0.2. So this is the minimum value, and this in range B, I'm going to change this to 24. So this is the valid time range between the dusk and midnight. And for this out range A, so the first value here should be -180. So our moon should come out at the spot where our sun goes down. And for this out range B, I'm going to change this to -90. So at around midnight, our moon should be at the highest point on our sky. Alright, this is the valid rotation after dusk. And now we need to handle the rotation before dawn. So I'm going to select these two nodes, select these two nodes, press Ctrl+D to duplicate them, and connect this pin to here. And 0 here means midnight, same as our 24. And for this in range B, I'm going to drag out this dawn time. And I'm going to subtract 0.2 from this dawn time. So this is the time range between midnight and our dawn. And this out range A, so this value here should be -90. And out range B, this one here should be 0. And I'm going to click compile. And go back to my level, I'm going to test this. Currently, the value for time of day is 18.2, and as I'm increasing the value, we should be able to see our moon rising from that direction, but currently we are not seeing anything. And if we look at our scene, our cube is indeed being properly lit. So this indicates our directional light is working. It's just that we lose our sky hemisphere. And if I change this value to be before dawn, so at somewhere around 4 AM, we should be able to see our moon at that direction. And if we look at our scene, so the directional light is working, but the sky hemisphere isn't. And the reason for that is currently there are 2 directional lights in our scene, and our sky hemisphere doesn't know how to handle that. So in order for this to work properly, we'll need to manually hide our sun and moon based on this time of day. And we'll look at how we can do that in the next lecture. And before that, I'm going to write some comments inside of my blueprint. So inside of this function, for these nodes, here we are handling sun rotation between dawn and dusk. And for these nodes, so here we are handling moon rotation after dusk. So the value I'm adding to this dusk time is 0.2, but actually here it needs to be 0.3. When the time of day is 18.2, our sun is still visible. So 18.3 should be the time that our sun disappears. And same thing goes for these nodes here. So I'm going to drag them out a little bit. So these nodes, here we are handling moon rotation before dawn. And the value I'm subtracting here, it should be 0.3 as well, not 0.2. Alright, I'm going to click compile. So this is the theory that I followed to set the rotation of our moon, and these are the nodes that I used. And feel free to use them as a reference if you need. Alright, it's time for you to implement this by yourself, and I'll see you in the next lecture.